In this lesson, we're going to talk about, in counting methods in probability, we're going to talk about the binomial theorem. And the binomial theorem is used really to expand a binomial that's raised to a power in a simpler way than multiplying all the binomials together. So let's take an example. Let's just say that we had x plus 4 to the 6th. Now, the purpose of the binomial theorem, or at least one of the purposes, is to be able to rewrite this binomial raised to the 6th fairly quickly, rather than spending our time multiplying x plus 4 times 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 x plus 4. So you get the picture. So there's a trick to expanding this binomial, and the trick is a certain rule that says that the coefficient of the first term in the expansion is going to be the combination of n choose 0. And the exponent of the first value, a, is going to be n, and the second value is going to be 0. Now, there are a lot of variables here. This looks very confusing, but there's a certain pattern. Once you start doing the problems, you'll see that it's actually very simple. So why don't we take a problem and let's work it out. This problem, actually we'll take problem, an example from your homework, a plus b to the 4th. So the first thing I want to do is I want to set up the combinations first. I know that there are actually going to be 5 different terms. There's going to be 1 plus this value here. So I'm going to set up my 5 combinations. I've got C, remember 4 choose 0. I've got C 4 choose 1. And remember, these are my coefficients of the terms. C4 choose 2, C4 choose 3, C4 choose 4. So see, there are 5 different coefficients in 5 different terms in this expansion. So if I go back and I take a look at my equation, I satisfy this. The coefficient is going to be n choose 0. Second coefficient is n choose 1. And I go on until I finish with n choose n. In this case, it's going to be 4 choose 4. So let's figure out what 4 choose 0 is. 4 choose 0 is just going to be 1. Okay? That's 4 factorial over 4 factorial. And 4 choose 1 is just going to be 4. That's 4 factorial over 3 factorial, which is just 4. And then 4 choose 2 is going to be 6. I've got 4 times, let's just make sure that's correct, 2 times 1, which is 12, 24, over 2 factorial, which is just 2, and 2 factorial. So I've got 24 over 4, that equals 6. And 4 choose 3 is going to be 4. 4 choose 4 is going to be 1. So I have my coefficients for each of the terms now. So I can continue on and expand. And now I'm going to tackle each of the individual values or variables in the expansion. So remember, we'll go back to our equation. The first variable, a, I'm going to take as a to the n. In this case, it's going to be 4. And then b is going to be to the 0. And anything to the 0, remember, is just 1. So I rewrite this. I'll take the coefficient of 1, which I don't really need to write, but a to the 4th, b to the 0. Then I add, again, my coefficient 4, a now to the n minus 1, which is a to the 3rd, b to the 1, plus 6, here's my coefficient again, a to the 2nd, b also to the 2nd, plus 4 is my coefficient, a now to the 1st, b to the 3rd, plus, now my last, 1 times a to the 0, which is just 1, so we won't write it, b to the 4th. So I can rewrite this simplified as a to the 4th plus 4a to the 3rd b plus 6a squared b squared plus 4a b to the 3rd plus b to the 4th. That's my expanded binomial. I've eliminated all of the values, the coefficients, and the terms that I do not need, and I've simplified it out, in a matter of a minute without having to multiply the whole thing out one by one. Okay, let's take another example. In this example, what do we do when the value is negative? Well, what we're going to do is we're going to treat negative 4 as if it's an entity of its own, let's say, and we're going to rewrite this as c times negative 4 to the 5th. Let's just put another set of parentheses here. So I figure out my combinations, my coefficients. So I have c5. Remember, they're going to be 6, or we're going to be one more than what value is here. c5, choose 0. c5, choose 1. c5, 2. 5, 3. 5, 4. And 5, choose 5. In this case, I know that this is going to be 1. This is going to be 5. In this case, let's work this one out. I've got 5 times 4 times 3 times 2 times 1 over 3 factorial, which is 3 times 2 times 1. And that's going to be 20, divided by 2 factorial, which is going to be 2. 20 divided by 2 is going to be 10. So here is my 10. And now 5 choose 3 is going to be the same as 5 choose 2. In 5 choose 2, I have 5 3 factorial, 2 factorial. And in 5 choose 3, I've got 5 factorial over 2 factorial, 3 factorial. So the value ends up being the same. It's 10. I know this is 5, and this is 1. So here I have my coefficients. Now with my coefficients, let's rewrite this. I have 1. Remember, c to the n. It's going to be c to the 5th. And now negative 4 to the 0, which is going to be 1 still, plus I have my first coefficient 5 times c now to the n minus 1, or 4, times negative 4 to the 1, plus I've got 10 here as my first coefficient, c to the 3rd, right? So I've got 5, 4, 3, and now I have 0, 1, 2 for negative 4, negative 4 squared, plus I have another 10 as a coefficient, c squared, negative 4 to the 3rd, plus I have 5, c to the 1, negative 4 to the 4th, and then my last one is going to be 1, and I'm going to have to write this in here, 1 c to the 0, which is 1, negative 4 to the 5th. Okay, so if I were to rewrite this, I don't need the ones here. I've got c 5, negative 4 to the 0 is just 1, so c to the 5th. Plus, in this case we have to be careful because we have a negative 4 to the 1. We're going to end up with a negative value. So we need to change this sign to a negative. So I have c to the 5th minus 20, it's negative 4 times 5, c to the 4th, plus, in this case I have a negative 4 that's squared, so it's going to be 16 times 10, which is 160. 160 c to the 3rd. Now this is going to be a minus because I have minus 4 to the 3rd, right, which is 64. 4 times 4 is 16, times 4 is 64. So I have negative 64 times 10, which is negative 640 c squared. Now I have plus again. Negative 4 to the 4th is 4 times 4, which is 16, times 64, which is 256. So I have 256 times 5, and that's a positive number. So 256 times 5 gives me, I'm sorry, times 5, that's right, it gives me 1280. In this case, it is going to be just c to the 1. And then lastly, I'm left with negative 4 to the 5th, which is going to be a negative value of negative 1024. And there's my answer. And again, if we think about the amount of time it would take to expand this, multiplying all these through, far less time to use the binomial theorem to solve.